Hello everyone. Today we are going to see op-amp inverting amplifier using software Tinker CAD. So this is an online software. So if you Google search it, you will come to this website tinkercad.com. So I already logged in. So you may need to log in for first time. Then once you log in, everything will be saved there, so it will save your lots of time. So go to circuit, then create one. So some name will be there, it's a random name. You click it and give as per your requirement. So here we are going to study op-amp inverting amplifier. So let's look at our circuit, then we will start. So if you see the circuit, the V in voltage is given to second terminal, that is inverting one, and 3 is a ground, non-inverting one. Then we have resistance Ri, that is the input resistance, and Rf is our feedback resistance, and which is connected between 2 and 6, and we will see output at V0. Also we require power supply plus VCC and minus VCC. So let's draw this circuit or make this circuit on Tinkercad. So for this, to making circuit, we require breadboard. So you can search here or browse from down. So here you can see it is here. So just drag and drop method, you will get here. You can zoom it if you want. Then we required plus VCC, so power supply. So again I will browse from here, so it's not there. Then you can see here now power supply. So we require two actually in a real practical. We use dual power supply, but here we don't have that facility, so therefore we will use two power supplies. So we will use for plus VCC this, so you can label here, so you will remember why you are using it. It's optional, you don't need to do it if you don't want to, but since we are learning, so it's better way to have it. So I will hide this thing. So when I require labeling, I will just put here, click. If I don't require, I switch off this. So I will consider this will be my plus VCC. So this is the wire. So color I can change from here. So plus VCC I will just give to our breadboard. So entire this line become plus VCC. Similarly, this will I give to ground, sorry, negative VCC. So for negative I will change the color to black. Second, we need a ground, so we will make one common ground. So for ground we will have color green, which is a standard one. So both ground we will join together. So this both are grounded now. We made a arrangement for VCC, plus VCC and minus VCC. Now we will make arrangement for V in. So again we record one more supply. So this is V in. So basically we can give a name also. Let me do here. So here is a 15 volts that I will give. Similarly, this was our minus VCC 15 volts, and this is V in. So we can vary later what depending on our requirement. So ground is common, so let me quickly put the ground together. So this entire is our ground and this entire we are minus VCC. Now we require IC. So we know the name 741, that is op-amp. So we will just drag it. So we got our circuit here. IC on breadboard. So if I zoom it, you can see here like a dot notch is here. So this is the 1 2 3 4 5 6 7 8. So it's a 8 pin IC. Just refer to our diagram. So these are the pin numbers, so same we can use for that purpose. So we have now IC, VI plus VCC minus VCC. Also we made arrangement for ground. Now we require RI and RF, which is input resistance and feedback resistance. So register is here only. So let me put register here. So name it RI. So we are doing for this is 1K, so it's fine. you can rotate using R. So this is going to 2 and VI. So same thing I will do. So this is terminal 1, this is terminal 2. So I will keep here, and let me finish this also. And let me change the color. So we can give input. Actually we can use red also. V in to register RI, it's going to 2. So basically we connected this circuit, input to RI one terminal and another terminal to 2 of IC. Now we need another RF which is in between 2 and 6. So RF which is 10 kilo ohm. Actually we can change later also our value. If I zoom it, you can see the color code also changing with number. So you can see here brown, black, red. So 10 into 10 raised to 2, that is 1 kilo ohm, and this is 10, orange means 3, so 10 into 10 raised to 3. So that way also you can verify. So let me rotate it again. So 6 I need to put in 6, 1 2 3 4 5 6. So I need to keep here. So one terminal gone to 6. Again we want to give to second. So that way I connected to 2 and 6. So this register is now connected between 2 and 6. So you can see terminal 2 and this will be at 6. So our basic circuit is ready. So for there is one more connection is required. So we need to connect 3 to ground. So 1 2 3. So this 3 we are going to connect to ground, and again I will change color to green to get the idea that it is a ground. Now for measurement we required voltmeter for input and output. So I will use multimeter 1. So this is for V in, and another one for V out. So let me connect here first. So both negative will go to ground. So I am taking long way, but it will not congest. That is our motive. So it is gone to ground. Now this is our input, so it should go to V in. So this is our V in. So this is a red wire. Similarly, V out. So V out is at 6. So same I will put here. So we need to give plus VCC and minus VCC to our IC. 7 will plus and 4 will be our minus VCC. 1, 2, 3, 4, 5, 6, 7. So 7 will be plus VCC and 4 will be minus VCC. That is black. So now our circuit is ready. So for gain, V out by Vi is equal to minus Rf by Ri. So V out by Vi is a in general formula for every gain. For our circuit, for inverting amplifier, Rf by Ri is a gain formula. So here we are using Rf 10 kilo ohm and Ri 1 kilo ohm. So naturally our gain will be minus 10. So let's start. So for beginning, I will give input as a 0. If circuit is okay, it will show us 0 0 value. So we can say our circuit is working fine. So I made this table for our data collection. So we will vary from 0.2 to 2 with increment of 0.2. So let's start. So first I will change 0.2. So you can see I am changing input voltage. So once I change, you can see the output. So that is a minus 2 volt. So that is minus 2 volt. So we can use the gain formula here. Which is V out by V in. So this divided by so we get the gain minus 10. So in real also we will get same thing, but due to some error in resistance on all that, we may not get 10 minus 10. It may be 9.98 or 9.8 something we will get, or 10.1. So depending on error, this value in reality will vary, but this is like a simulated version, so we are getting exact value. Now we will vary to second input, that is a 0.4. So output is minus 4. Then we will vary to 0.6. You see output is minus 6. Then will we vary to 0.8. Then you can see output is minus 8. Then we will vary to 1. Output will be minus 10. Now we'll vary to 1.2, that is a 12 minus 12. Same gain we will get. Okay, so up to this there is no problem. We will get minus 14 as per our formula. It will go, but here we will see what will happen at this. So I will give you 1.6. So here you can see output is minus 14.9. So why this happening? Because op-amp is now in saturated mode. So when it goes to saturated, why? Because our input are only plus VCC is a plus 15 and minus is a minus 15, so it cannot go beyond that. So therefore it is on in a saturate mode. So we will get here only minus 14.6. Output should be input into gain, so that should be 16, but since we have due to saturation we will get only 14.9. Similar thing will happen at further also. Let's do that. Again 1.8 is input, output is minus 14.9. And for 2 is remains same because our op-amp is in saturated mode. So quickly we will plot the graph. So manually you can take this much point, but since we are doing using computer, so we will take up to where it's not in saturation mode. So we will get this output. Let's find out the slope. Which is minus 10 as we expected. So hopefully you learn how to do experiment using Tinker CAD. Thank you.